All right, tonight's lesson is going to be Introduction to Trigonometry, and we're going to begin talking about the trigonometric ratios of sine, cosine, and tangent. So we're looking at angle A, which is the angle right here. So the sine of angle A is going to be the length of the leg opposite angle A, right here, divided by the length of the hypotenuse. So A divided by C. And we can think of that as O over H. Look at the cosine of angle A. Now we're looking at the length of the leg adjacent to angle A, which is angle B, divided by the length of the hypotenuse C. Or we could look at this as A over H. And finally, we have tangent of angle A, and the tangent has everything but the hypotenuse, so it's the length of the leg opposite angle A, which is side A, and the length of the leg adjacent to angle A, which is side B. And we could look at this as opposite over adjacent, or O over A. So the way to remember this is SOHCAHTOA. SOHCAHTOA. You can make up all sorts of things with SOHCAHTOA if you would like to remember it. But SOHCAHTOA, opposite over hypotenuse is sine, adjacent over hypotenuse is cosine, and tangent is opposite over adjacent. So we're going to draw a line from each trigonometric ratio in column A to its corresponding ratio in column B. The sine of B, so let me erase the board here. Hope you got all that. The sine of B, here's B, is going to be the opposite, which is B, over the hypotenuse. So B over C. The cosine of B is going to be the adjacent, A, over the hypotenuse, C. And that leaves our last choice, the tangent of B. So suppose triangle ABC is a right isosceles triangle. What would the tangent of angle B equal? So here's our triangle, and we're going to go A, B, C. So the tangent would be 1 over 1. I'm saying this is a 1 over 1 square root of 2 triangle. So our tangent would equal 1. So let's erase all this, and we're going to continue on to our next concept. All right, so how do we write trigonometric ratios? Let's trip over that word all the time. So we're going to write each trigonometric ratio for our triangle GRT. So the sine of G, we're dealing with this right here. We're looking at angle G. The opposite is 15 over the hypotenuse, 17. So the sine of G is the ratio of 15 over 17. Adjacent is 8. And the hypotenuse again is 17. So the cosine of G is 8 over 15. And finally, the tangent of G is opposite, 15 over adjacent, 8. So that's how we find trigonometric ratios of triangles, right triangles. It's very simple. You just remember SOHCAHTOA. Here's my board. Using trigonometric ratio to find distance. So in my drawing here, I have triangle, and let's call it ABC. and I want to find the value of W to the nearest tenth. I know that the sine of A equals opposite side over the hypotenuse. But actually, I'm giving the measure of A, so the sine of 54 degrees equals W divided by 17. When the value that you're looking for is in the numerator, all you do is you multiply sine of 54 degrees by 17. Multiply both sides by 17. The right side will cancel out, and I get W equals 17 times the sine of 54 degrees. And tomorrow we'll talk about how you're going to put this in the calculator. You just have to have the right mode set on your calculator for degrees, and it'll put out an answer, and the answer is approximately 13.8. So our distance W is approximately 13.8. Now, let's say maybe we knew that our W was right here, and I wanted to find that distance. Then I would have done the cosine of 54 degrees equals W over, excuse me, okay, let's try that over again. Let's say that my 17 happened to be in my opposite side, and my W happened to be on my adjacent side. This changes my equation a little bit. I could do tangent of 54 equals opposite over adjacent. The reason I did this problem this way is to make sure that I had a variable in the denominator. When I have a variable in the denominator, in order to solve this problem, I would multiply both sides by W. My W's would cancel out, and I would get W tangent 54 equals 17. And now to solve for W, I have to divide by 54, tangent of 54, and I'll get W equals 17, the tangent of 54. So what happens for my original problem is essentially my W and my tangent trade places. So when you have a problem where you're looking for a variable in the denominator with trigonometric ratios, you simply swap the trigonometric value to the bottom and move the variable up over to the left. So you swap them basically. So I get W equals 17 divided by the tangent of 54. I just wanted to show you a different problem that you'll have to solve differently. These are two ways to find distances using trigonometric ratios. All right, using inverses. We want to use the figure below to find the measure of angle Y. Okay, I know this is angle Y, and I know the side opposite, and I know the side adjacent. So I know the leg opposite and the leg adjacent. So when I have opposite and adjacent, I think tangent. So the tangent of Y equals 100 over 41. So now I'm going to take the inverse tangent of both sides. So the inverse operation of tangent is tangent inverse. So the measure of angle Y equals the inverse tangent of 100 divided by 41. And yes, it actually exists on your calculator. You do second tangent or second inverse tangent. It's the blue button above the tangent button. And I will get that the measure of angle Y is approximately 67.7 degrees, or we'll say 68 degrees. So you use the inverse functions in order to find the measure of an angle. So if you're looking for distance, you either multiply or divide. And if you're looking for an angle, you use an inverse function to solve for the angle. So that's tonight's lesson on trigonometry. It's a quick lesson on trigonometry. If you still want some more information, go get that Getting Triggy With It video to watch that, and it'll go over everything I just covered in this video. So everybody have a good night, and I will see you tomorrow.